Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will talk about constructive solid geometry in FreeCAD and how constructive solid geometry used in a part workbench. And before directly going to understand the constructive solid geometry, first we will understand the geometric model kernel. If you want to learn FreeCAD from the scratch, then you can buy my complete FreeCAD course from zero to expert. This course also available on Udemy, but problem is that Udemy only give me the 37% of a course selling. You can see here user had paid $15, but I have only got $5. If you wanted to see the review of my course, you can go to the Udemy and search for the FreeCAD, and you will see my course, complete FreeCAD course from zero to expert. And this course is took by the more than 2000 students, and I have got the rating of a 4.1. For the demo lectures you can expand it and see the demo lectures and the course structure. But I will request you, if you found my course interesting and the reviews of the other student on Udemy, then I would request you to buy my course from my coffee shops, because if you buy from here it will help me a lot. So once you buy my course, you will be redirected to the Google Drive, and here is the my course, complete FreeCAD course from zero to expert. Go inside, and the sections I have shown you on my Ko-Fi shop page. So exactly same lectures under the section is created. For example, section 1 is introductions to FreeCAD 1.0 and what is new in FreeCAD 1.0. So if we go to the section 1, so there are the 18 lectures, and if you go inside of this sections 1, you will find the 18 lecture total. And once you go to the lecture 1, you will find a video file which you can download to your system, and you can watch it. And this course is updated on a equal interval of a time once the new features came, and once you purchase the course, you have the lifetime access to the course. And in the case of any doubt, any query, you can mail me at admin@mechnexus.com. You can find my course link on my YouTube channel. You can see the course link, and you can also find my Ko-Fi course page link on pin comments and video descriptions. So basically, a geometric modeling kernel is a solid modeling software component used in a computer aided design, means in CAD softwares. So you have heard about the so many CAD softwares like SolidWorks, CATIA, Unigraphics, Creo. So how this CAD softwares works? So core of the every CAD software is a geometric modeling kernel. Here we can see that ACIS is developed by Dassault System, Parasolid is built by Siemens, and PTC have developed the Granite. And here in a list we can see here Open Cascade, which is an open source modeling kernel, and our FreeCAD software is powered by this Open Cascade. So let's see the Open Cascade Wikipedia page. So this is the open source, and here you can see the release date of Open Cascade. And now come to our point, which is a constructive solid geometry. It is a modeling paradigm that is used in many CAD systems. Almost any software which is an open source is powered by the open cascade in many cases, whereas in paid softwares like SolidWorks Inventor, they use the softwares from here. For example, this Siemens build the Parasolid, and this Parasolid is used by the many companies, and Dassault's having their own modeling kernels. If we look at the list, there are the few kernels which are the very known in the market, but our main focus is Open Cascade. And here, what is constructive solid geometry? We have known the kernel and how this kernel is useful in a CSG. So basically, constructive solid geometry is a primitive solid objects where we model the part with the help of a Boolean operations. So here we have the modeling kernels, and here we perform the Boolean operation. Boolean operation basically is a addition and subtractions of a part. So we can see here these three cylinders are the combined together to make a single body. So here we have did the addition of a part, and here we have combined this cube and this round, and we have achieved the shape with the help of addition and subtractions. After that, this body and this body got added, and after the additions this body got subtracted from this, and we have achieved this part. So this is how we use the primitive objects. Primitive objects is nothing but, if you go to the FreeCAD and we activate the part workbench, so primitive objects are the cube, cylinder, round. These are the primitive objects, and we will see the practical example of this. And here is a beautiful graph is given, or we can say the diagram, where we can see that we create a sketch, then we extrude it, create a solid, or we create a solid directly, and then we perform the operations like a union, cut, again cut, and here we achieve our final objects. So to understand this Boolean operation, we will do one live example in a part design workbench with the help of a constructive solid geometry. We will use the primitive solid objects and we will perform the Boolean operations. So in constructive solid geometry, we have to focus on these two things: use the primitive objects and use the Boolean operations, and rest of the things in background is handled by our modeling kernel. So now let's come to our FreeCAD, and here I will simply click on the cube. So I will go to the model tab, and if I select this cube, then I get its property like how much length, height, and width. So here is a 10 mm by 10 mm by 10 mm. Now let's give the length 100, width 50, and let's give the thickness of a 5 mm. So you can see that by just changing the value, I have converted the cube into the plate. Now let's consider we wanted to create a hole on this plate, but we will do it with a primitive solids. So create a hole, we will insert a cylinder. So you can see that one cylinder is inserted here, and now if I click on the cylinder, I get its property. So let's see, I wanted to give the diameter 5, so I will give the radius 2.5, and height, let's give the 20. It doesn't matter because we will move it and we will perform the Boolean operations. And now here is the interesting thing is that is a placement property. So it is placed on 0 0 0. So let's see, if I click on the top view, and here is our UCS, you can see that in Y directions. In Y directions, I want the position of the cylinder to the 30 mm. So you can see that it is moved to the 30, and I wanted to make it 20. or let's make it 15, and in X directions I will give it a 15. So you can see that my cylinder has moved with the respect to the X, Y and Z value. So in Z I wanted to cut it, so in Z directions I will move it to the down. So we have fixed the position of our cylinder, and now we perform the Boolean operations. So in Boolean operations, selection of order is very important. We wanted to subtract this cylinder from these plates. So first we will select the plate and press the control key, and we will select the cylinder. And now we will get the Boolean operations tools here. So this is the union, this is the intersection, and this is the cut. So we will perform the cut operations and click on the cut. So you can see that cylinder is subtracted from this plate, and we have created the hole. And now let's on this cylinder, we can on it, and let's change the property. For example, I wanted to increase the hole dia. I make it 5, so you can see that it has been updated. And if I wanted to change the positions, then I can simply go here and change the positions. On it, click on the cylinder, and here we can change the position. For example, I move it here, and you can see that as I move my cylinder, my hole is also shifting because of the parametric nature of our FreeCAD. Now if I come out of it, then my hole is also moving. So this is how we can create the features, and this is just basic understanding to understand the Boolean operations in FreeCAD. And when we do the modeling, then you will have the better understanding of a FreeCAD Part Workbench. Now let's delete it. And what if I wanted to combine it, this cylinder and this plate, a single body? So I will select the plate and cylinder, and here I will perform the union tool. So now the cylinder and this got merged, but you are seeing the edges here. So what I will do, I will go to my fusion, which is a union, and here is a refine is a false, so I will set it true. Now it got merged. Now it is a single body. Let's delete it and delete this cylinder. I wanted to combine two plates. So what I will do, I will select my cube, go to the edit and click on the copy, and again go to the edit and click on the paste. So now here we have the two plates, and our plate thickness is of 5 mm. So I will select it, go to the placement, and in position in Z direction I will give the 5 mm. Now we have the two plates. Now we will combine it and make it a single plate. So for this we will select these two plates and click on the union. So it is got merged, but you might think that if it is combined, then there is a parting line is there. So for this we will go to the fusion, refine is false, we will set it true. So now you can see that these two plates are got merged. So this is how Boolean operation is work. And here is the intersections. I wanted to insert a cylinder, I have inserted it. Now I wanted to intersection portion if I want it. So I will select my fusion and select cylinder and click on the intersections. So I will only get the intersections body. So this is how to use the Boolean operations with the primitive solids in FreeCAD to model the part. So this is all about how to use the part modeling in Part Workbench with the help of constructive solid geometry in FreeCAD. I hope you have got the basic idea of the Part Workbench, and when we will do some modelings, mechanical part modeling with the help of a Part Workbench, then you will have the better understanding of the other tools in a Part Workbench of a FreeCAD. So this is all about this tutorial. Thank you for watching and thank you for your valuable time.